All right, good afternoon, ladies and gentlemen. What we're going to do today is we are going to talk about the Pythagorean theorem converse. So, in our introduction, you heard me talk about this and you heard me say some of these words before, but we don't quite know what they mean. So, what we're going to do is we're going to review a little bit. I'm going to introduce what the Pythagorean theorem converse is. We're going to practice a couple questions together, and then I'm going to have you practice some on your own. Now, if you have any questions, please make sure you ask. During this video, I'm going to ask you to write some of this stuff down, so pause the video if you need to. Take your time, make sure you follow along, and do what you need to do to make sure that you understand what the Pythagorean theorem converse is by the time we are done with this video. So what we're going to do here real quick is we're just going to review a couple of things. And by that, all I mean is we're going to go over some of these answers here. You should already know these answers before we even go over them, but we're going to go over them anyway. So number one says the Pythagorean theorem helps us find the sides of a blank triangle. So we all know that this helps us, or the Pythagorean theorem helps us find the sides of a right triangle. So please make sure you write right triangle in there. And if we think about this, once again, we know that we have a right triangle. So let me draw a little right triangle here. It has that little box on the side so we can identify it as a right triangle. We have sides A, B, and C. And we should know that once again as we go through all of this. So number two, the longest side of a right triangle is the blank. So if we look up here at the right triangle that I just drew, C is the longest side, and that is known as the hypotenuse. So we have the hypotenuse of the triangle, which once again is the longest side, and it's always opposite of the right angle. Finally, number three says the formula for the Pythagorean theorem is a squared plus b squared equals c squared. And this again is going to become very important when we go over the Pythagorean theorem converse and what it is and what it means. So make sure you have these three fill in the blanks filled in on your worksheet. Like I said, make sure you are following along as we go over some of this. So what I want to do here for the fourth bullet point under let's review is let's talk about how to find the missing side lengths of a right triangle. And once again, I'm going to draw in our right angle here just to make sure that we know that it's a right triangle. So we have a right triangle here that has the side lengths of 4, 7, and x. And we don't know what x is, and that's the side length that we are trying to find. Well, once again, we know that we can label this, or we can label the side lengths A, B, and C, and I know that this is side C because it is opposite of the right angle. So as we go over some of these things, I know that I can identify point C or side C, and that is the side that we are trying to figure out. So once again, it's always smart to start with writing down the Pythagorean theorem. So a squared plus b squared equals c squared. And I already identified some of the sides for you. We know what a and b are, so we can go ahead and plug those in a while. So I can say that 4 squared plus 7 squared equals c squared because we don't know what side c is. So let's simplify what some of these are. 4 squared is 16. 7 squared is 49. And once again, we don't know what c squared is. So you should make sure that you are following along and writing all of this down. Now we need to add 16 plus 49. And if you need to do that on your calculator, that's perfectly fine. And if you don't, and you can do it in your head, that's great as well. But 16 plus 49 is 65. And we can say that that equals c squared. Now the last thing that we need to do, and once again this is very important, is take the square root of both sides. And we can say that the square root of 65, if you put it in your calculator and you round it to a nice number, I'll give you guys 10 seconds to do that real quick. the square root of 65, we can say that C equals 8.06, or you can say 8.1. And that is the answer that we are going to have. So circle it, and we know that we've found our missing side length. So now that we've reviewed some of the things that we should know, and we did an example of finding a missing side of a right triangle using the Pythagorean theorem, there's one more thing that I need to introduce to you about the Pythagorean theorem, and that is the Pythagorean theorem's converse. So I'm going to underline this word, and once again, the converse of the Pythagorean theorem. Now you might be thinking to yourself, Mr. Wanamaker, I have no clue what that means, and that's why I'm going to go over it with you. So the biggest thing here and the most important thing is when given 3 side lengths, okay, you have to be given 3 side lengths because, once again, we know that triangles have 3 sides, and we are given 3 side lengths. And what I need to write more than this is when given 3 side lengths, the sum of the squared legs equals the sum of the squared hypotenuse. So take a second to write that down. When given 3 side lengths, boom, that's important. The sum of the squared legs equals the sum of the squared hypotenuse. So some of you might be thinking, what does that mean? I need some easier terms to think of, and let me go over that with you right now. So let's think here. I just told you what converse meant as a definition, but what does it truly mean when we look at something? So once again, converse. And you don't have to write this down, just follow along with me. The converse of the Pythagorean theorem. We know that a squared plus b squared equals c squared. We're given 3 side lengths. So we're given side A, side B, and side C. And I'm telling you that the side or the sum, which when adding 2 things together, we get a sum, 2 or more things. So the side of the legs, A and B, have to equal the hypotenuse. Okay, which in this case is side C. So once again, follow along with me here. So what I'm saying is that the sum, after we square all these things, a squared plus b squared, their sum equals the squared hypotenuse. So it's important to know, once again, that both sides of the equation equal each other. So you don't have to write this down. This is just me explaining what some of this means. But when using the Pythagorean theorem converse, both sides equal each other. So now that we know what the converse is, we can kind of try it out. So what I want to do here is I want to take some time to go over 2 questions with you. One, part A, is going to be going through an example where it's a right triangle and we're given all 3 sides. Part B is we are given 3 lengths of what we don't know or we need to prove is a right triangle. And once again, we need to make sure that both sides are equal to each other. So as we dive into this, it's always important to label your sides. So once again, this is the right triangle. I draw in my 90-degree angle. We always know that across from the 90-degree angle is side C. And if you can identify this first, you are already on the right track because then you can just put in A and B as your legs. So after we do this, we can now start. And we once again know that the Pythagorean theorem says a squared plus b squared equals c squared. And I just fill in all of these letters. So I fill in a, b, and c. And if I do that, I now have 3 squared plus 4 squared equals 5 squared. So once again, filling in all the sides to the appropriate letter. So now we need to simplify. 3 squared is 9, 4 squared is 16, and 5 squared is 25. And like I said earlier, this side should equal this side. So let's make sure that they are equal to each other. 9 plus 16 equals 25, and this equals 25. So are they equal to each other? Yes, they are. It checks out. And can we say that this is a right triangle? Yes, we can. So once again, both sides are equal to each other. The converse has worked, and we are good to go. So like I said, now in part B, we are given 3 side lengths, and we must prove that this is a right triangle. Once again, we use the Pythagorean theorem the same way we just did, but now we just don't have a picture of a triangle, and that's perfectly fine because we can figure this out anyway. So when given a list of 3 sides, you need to think to yourself, which one is the longest side, because the longest side represents the hypotenuse. And I'm going to make a little circle, or I'm going to draw a circle around 13, because out of the lengths of 5, 12, and 13, I know that 13 is the longest side. So 13 has to be my hypotenuse, which I'm going to say is C. Now I could put A and B here for 5 and 12, but it doesn't really matter since I already have identified what length is side C. So once again, we start by writing the Pythagorean theorem, a squared plus b squared equals c squared. I plug in for what I already know, so a is 5, so I plug that in for 5 squared. B is 12, so I plug that in for 12 squared, and C is 13, so I plug that in for 13 squared. Biggest thing here is that we simplify. 25 is 5 squared, 12 squared is 144, and 13 squared is 169. Now, you take a second and you think about what we just did. We need to know that this side is equal to this side. So if you take 25 plus 144, you get 169. And 169 equals 169. So think to yourself, are these two equal? Yes, they are. So I can say here that yes, these lengths make a right triangle. So once again, we've proved that the Pythagorean theorem helps us once again find now the converse, which is once again when given 3 sides or 3 lengths, we can use the Pythagorean theorem to prove that they make a right triangle. So now that we've gone over a couple of problems together, I want you to go to IXL to practice some of these things, and I want you to go to IXL to practice the Pythagorean theorem converse. With that being said, when you log on to IXL, it's under Geometry and Q2. So that is where you're supposed to be going. Make sure that you are practicing. If you have any questions, please ask. Refer to your note sheet as you are doing some of these problems. Make sure you are following along. Thank you for writing down some of these notes, following along with the worksheet, and doing what I asked you to do today. Thank you.